Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Today, I'm going to explain two things. Number one, why a set is always a subset to itself. I repeat, why a set is always a subset to itself. Okay, that's number one. Number two, I'm going to explain why an empty set is always a subset to every set. Okay, let's write down the definition of a subset. If A and B are sets, okay, if A and B are two sets, then A is a subset of B. We say that A is a subset of B if and only if all elements in A is also an element in B. Okay, that's what we have to check. Okay, in order for us to be able to say that A is a subset of B, what we have to do is we have to check all elements in A, whether all of them also appear, okay, in set B. If we find out that is true, then we say that A is a subset of B. Now, let's look at this example here. A, suppose that we are given set A is equal to 1 and 2 elements, and also we are given set B, okay, with 3 elements, that is 1, 2 and 3. Now we want to decide whether A is a subset of B. According to the definition, what we have to do is we have to check all elements in A whether it's also appear in set B. Okay, now let's see. 1 is in A, it also has in B, yes, 1 is okay. How about 2? Yeah, 2 is in A and also 2 is in B. Therefore, all elements in A is also an element in B. Thus, we can conclude that set A is a subset of set B. Okay, therefore, A is a subset of B. Therefore, A is a subset of B. Or we can write it in terms of symbol. We say A is a subset of B using this symbol. By using the same set, that is A equal to 1, 2. A is a set of 1, 2. And set B equal to 1, 2, 3. Now this time we want to check whether B is a subset of A or not. So question is B is a subset of A? So what we have to do is we want to check every element in B whether it is also in A. Okay, the other way around. So we want to check whether every element in B also an element in A. So let's see. 1 is in B. Okay, and 1 also in A. 1 in B and also 1 is in A. Okay. Element 1 is okay. Okay, appear in both sets. Now, element 2, yes, we have in B. And also 2, also we have in A. And 2 also we have in A. So this okay, this also okay. Now in B, we have one more extra term, or what we call extra element, that is 3. 3 is in B, but 3 is not in A. 3 is in B, yes, we have, but 3 is not in A. Okay, therefore, set B is not a subset of A. Okay, because not every element in B also an element in A. Okay, therefore B is not a subset of A. Why? Because there is one extra element in B that is not in A. All right, let's talk a little bit more about these two sets. Set A equal to a set with element 1, 2, and set B is a set with element 1, 2, 3. We already discussed that set A is a subset of B because all element in A also an element in B. All right, 1, 2 here, also we have 1, 2 in set B. Therefore, set A is a subset of set B. This type of subset is called proper subset. We call it proper subset. Okay, because there is at least one element in B, all right, that is not in A. For example, in this case, we have this element 3 here, is in B, okay, is in B, but it is not in A. Meaning to say, B is bigger than A. Or we say, set A is contained in set B. If we write down in terms of Venn diagram, we have, okay, A is inside. This is A, and this is B. Okay, if we want to include the, what we call the element also, set A consists of 1 and 2. So we have 1 there, we have 2 here. Okay, there is one element 3 that is in B, but it is not in A. So where 3 is supposed to be written? Okay, in which area in this Venn diagram? Yeah, it's supposed to be here. It is outside of A. Okay, because it is not in A. 3 is not in A, so it is outside of set A, but it is inside set B. Inside B. Okay, 3 is in B, right? So this is the Venn diagram to show that in this case, set A is contained in set B. All right, inside set A is inside set B. This is what we call proper subset. Now the question is there what we call improper subset? Okay, in order for us to be able to explain about the improper subset, let's use the same example, set B. Okay, set B with 3 elements. That is, we have set B equal to with 3 elements just now. That is 1, 2, and 3. Okay, and let's write down one more time, set B down below this one. Okay, B, set B equal to 1, 2, and 3. Okay, the same set. We just write it 2 times. Okay, now we want to check whether this set is a subset of this set. What we have to do, according to the definition, is we have to check whether, okay, each element in this set is an element in this set also. All right, let's see. 1, we have down up here, we have down here. 2, we have here, we have 3 or 2 also here. 3, we have in this set, and also we have 3 in this set. Therefore, we conclude that this set B, therefore, we conclude that set B is a subset of set B. This set, okay, is a subset of this set. Again, because every element in this set is also an element in this set. Therefore, any set is a subset to itself. Any set, not only this set, this particular set. Every set, okay, is a subset to itself. Okay, this type of subset we call improper subset. Improper subset. Improper subset. I hope you still remember about empty set. Yeah, by using this symbol here. Empty set, right? Empty set. Or we can use this symbol also, curly bracket, to represent empty set, right? Still remember? Yeah, this is a set. Okay, but it is an empty set. A set that is empty without element inside. Let's create another set we call D. This one. Let's say D have 2 elements. There's 3 and 4. Okay, both of them set. So whenever we have two sets like this, we can check whether one is subset of the other. All right, so what I want to know now is that I want to check whether empty set is a subset of set D. That's what I want to check. Is this true or not? Is empty set is a subset of D? That's the question, right? So according to the definition, in order for us, okay, to decide whether a set is a subset of the other set, what we have to show is that all element in this set, okay, is also an element in this set. But this set is an empty set. There is nothing inside. There is no element inside. So what we have to do is maybe we have to think the other way. Let's show that empty set is not a subset of this set. Okay, let's think that way. Now, to show this is not a subset of this set, what we have to show is that there is at least one element in this set that is not in this set D. But this is an empty set. There is nothing inside. So we conclude that this empty set is a subset of this set D. Not only that, okay, empty set is a subset of every set.